Our today topic is IP addressing. Okay. So, what is IP addressing? When we do communication between two or more devices over the internet, we need an address which is known as IP address. Also, I can give you another example that when we want to go to our friend's house, we need an address, right? And also, I can share you another definition of IP address, which is over the internet, that IP address is a unique numerical identifier for every device or network that connects to internet. Okay, so we have two addresses. First is physical address. Second is our logical address, which is known as IP address. Let me give you the example of physical address. This is our system. This is our CPU, which has a slot of a LAN card. Which LAN card has a unique address known as MAC address. Okay, this is our MAC address is our physical address. Okay, so we have also two types of IP address. First is with IPv4 and second version is IPv6. Today we will discuss about the IPv4 version. Okay, so our IP address is provided by INA. Okay, and our IPv4 has 8 into 4 bits logical address, which we can say that 32-bit logical address, and IPv6 has 128-bit logical address. Okay, so another question arrived that what is bit? Bit. Bit is the machine language, or we can also say that computer language. Okay, so our IP address is divided into octet, 4-octet. IP address is divided into 4 octet. Let me give you the example. Just it is our IP address 103.106.5.127. Okay, this is our first octet. This is our second octet. This is our third octet. This is our fourth octet. Okay. Another question right. Why we call it octet? Right? Because these octets are combination of 8 bit. Okay, dear. Also, our IP address is equal to network address, network IP plus host. Okay. So, how our machine language is written like this 01101. And what is our normal is this decimal 1, 2, 3, 4, 5, 6, 7, 8 more. Okay. This is start with 0, 1, 2, 3, 4, 5, 6, 7. We can also convert binary to decimal or decimal to binary. Let me start with this. First we convert binary to decimal. We have a formula to do this. Okay. Our language starts with 0, 0, 1, 2, 3, 4. That we also know that it has 8 bit. So start with this. 1, 0, 1, 1, 0, 1, 0, 1. Okay. So the formula for this is 2 is to power n multiplication of our bit. Okay. Let me start. 2 is to power 0 first into our first bit, which is 1. Last first bit, which is 1, right? Is to power 0 into last bit 1. Then add 2 is to power 1. Last second bit 0. Then 2 is to power 2 into last third bit is 1. Add 2 is to power 3 into last fourth bit is 0. 2 is to power 4 Last fifth bit is 1. 2 is to power 5. Sixth bit is 1. 2 is to power 6. Seventh bit is 0. Add 2 is to power 7. Last bit is 1. Now let me solve this equation. What come? 2 is to power 7 is 128. Then 2 is to power 6 is 64. 2 is to power 5 is 32. 2 is to power 4 is 16. 2 is to power 3 is 8. 2 is to power 2 is 4. 2 is to power 1 is 2. 2 is to power 0 is 1. Right? Then we put this arbitral value 0, 0, 1, 1, 0, 1, 0, 1. Then we solve it. 128 into 1, 128 plus 64 into 0, 0, 32 into 1, 32. Add 16 into 1, 16. Add 8 into 0, 0. 4 into 1, 4. Add 2 into 0, 0. 1 into 1 equals to 181. So what come? Our decimal value. Okay. Let me do with another example. That's 2 is to power 0 into 1. Our last bit is 1. Next. 2 is to power 1. Our second bit is 0. Next. 2 is to power 2. Third bit is 2 is to power 3. Last fourth bit is 0. 2 is to power 4. Last fifth bit is 1. 2 is to power 5. Sixth bit is 1. 2 is to power 6. Seventh bit is 0. And 2 is to power 7. Eighth bit is 1. Now again resolve this. The value what come? 2 is to power 7, 128, 64, 32, 16, 8, 4, 2, 1. Then we put our binary value 1, 0, 1, 1, 0, 1, 0, 1. So multiply this. 128 into 1, 128. Add 64 into 0, 0, 32 into 1, 32, plus 16, plus 4, plus 1. What value will come? What value will come? Here. Solve it. Again, 181. I think I again do. Otherwise, let me give you another examples to take the practice. Please do the screenshot and do the practice of this. Let me write. Convert this binary into decimal. Okay then. So let me also convert some. Our octet starts with 0, 0, 0. First octet is this. What's our last octet? All these 0 are 1. Let me write in our 8-bit. So after resolving, what will become? After resolving this, what will come? 2, 2, 5, 2, 5, 5, 2, 5. So our first IP address is 0 and last is 255.255.255.255. Then our next is so our maximum value is 255 of the octet and 0 is our minimum value. So our next is conversion of decimal to binary. So our decimal value is 178. Just like above, we do the 2 is to power 10 into the bit, right? We can also take the shortcut. We also know about the 2 is to power 1 what is, 2 is to power 2 what is. So let me write this. Let me write simply the value of this. 2 is to power 7. 2 is to power 6. I am explaining you the shortcut of this, right? In this shortcut. So check where 178 lie between. Big is the 128. So let me minus 178, subtract 128. What comes? 50. So I put 1 below 128 because I used it. Then where 50 comes between 64 or 32. So what is less than 50? 32. So let me subtract 32 from 50. It will come 18. So now I put 0 on 64 and 1 on 32. Okay. Then where 18 lie between 32 and 16, and which is smallest than 18? 16. So I subtract 16 from 18. What come? 2. So I put 0 on 16 and 1. What I have minus? Sorry, by mistake. I put 1 on 16 and 0. 1 on 16. Okay. Then what comes? 2 subtract by 2. 0. So I put 1 on 2 and on others I will put 0. 0, 0 and 0. But the value will become 0, 1, 0, 1, 1, 0, 0, 1, 0. Right? This is the shortest way to convert the decimal into binary. Let me take another example for you. 190. Okay. So let me put the values. 128, 64, 32, 16, 8, 4, 2, 1. Okay. So starts with this 190, subtract 128. What will come? 62. So I put 1 on our 128. Then where 62 comes between 64 and 32. So subtract 62 by 32. What will come? 30. So I put 0 on 64 and 1 on 32. Then where 30 comes between 32 and 16. So I subtract 16 from 32. What it will come? Subtract 30. By mistakes, I have written this 30 minus 62 is equal to 14. So I put 1 on 16. Then 14 comes between 16 and 18. I subtract 16 and 8, sorry. Subtract 14 with 8. Fourteen subtract 8 is equal to 6. Okay. 6 comes between 8 and 4. Then 6 subtract by 4 is equal to 2. I put 1 on 4, then on 2 subtract by 2. So 1 on 2 and 0 on 1. So what is our binary value of the of 190 is 1 0 1 1 1 1 0, right? Let me give you some examples to do for the practice. Please take a screenshot of this and practice it. Okay, dear? Okay. So let me go to another topic, right? This all are clear? Okay. Our IP address is divided into classes. So let me first tell you about what is the ISP doing and what's this is our INF. This is our ISP. And these are our hosts. Right? I know. ISP. ISP providers. And this is the host. I now provide you. Right? So our IP address is divided into some classes. Class A, class B, class C, class D, and class E. Okay. Class A has the IP addresses of range 1.0.0.0 to 126.255.255.255. Okay. Class B IP address ranges are 128.0.0.0 to 191.255.255.255. Okay. So one range is missing. Which one range? 127.0.0.0. Why it is missing? This is the loopback range of IP. Loopback range of IP. It is used at the time of remote desk. Okay. So our next class is class C. IP addresses ranges. What is this? 192.0.0.0 to 223.255.255.255. Next class is class D. 224.0.0.0 to 239.255.255. 255.255. And class E IP address range is 240 to 0.0.0 to 255.255.255.255. Right? So these two classes, class D and class E, is fixed for the defense research and development. It is given and reserved. We can say that reserved for the defense research and development. Okay. That we have discussed how INA gives to the ISP and they will provide the host. Okay. So let me tell you other things that class A has this types of host. What class will given 1.0.0.0 to 120 126.255.255.2, right? So in class A, we have first bit as a network and other three are hosts. We can also write it like this. So how much we can give the IP address? First 255.6.0 starting from 0, no, right? So it will do 256 into 256 into 256. How many network IP we can assign is 167. This much we can assign the networks in class A. In class B, our two host is fixed and 2 is fixed for network. What is our class B range is, dear? I already talked about that. 128.0.0.0 to 191.255.255.255. Okay. So in our class B, 2 is fixed for host and 2 is fixed for network. So how much IP we can assign? 256 into 256. 65536. This much IP we can assign with class D. Then is our class C, in which one host bit will be given and 3 are fixed. Written as this and n.n.h. And this IP starts with 192.0.0.0 to 223.255.255.255, right? So how much IPs we can assign is 256, right? Through class C. Then we need to talk about the subnet mask. We need a PC or a hardware. Additionally, need an information such as subnet mask. Okay. So what is the subnet mask? Class A subnet mask is 255.0.0.0. Class B subnet mask is, which is, it has two fixed. So we can write this 255.255.255.0. And class C has three fixed 255.255.255.0. Oh, sorry, I have read mistakes. This is okay. Then in the next video, we will discuss about the subnetting. Okay. Thank you for the today, dear.